My name's Ilya. The urge to email me. My email address is on there. So the agenda, the things we'll be talking about. Oops. Some general information about fuzzing. If you've got no clue about what fuzzing is, these 2 or 3 slides will give you an introduction. Then I'll run by some of the most known and most used fuzzers, tell you what they do, some of the things they broke. Is it? Oh, thank you. Is this better? Okay. So I'll run by the most used fuzzers these days, tell you what they do, some of the stuff they broke, some additional information, and for some of those, I'll have demonstrations. That's the first part of my talk. The second part of my talk is basically about the things you need to build your own fuzzers or extend currently existing fuzzers. And then there will be a conclusion. So, general fuzzing information. Fuzzing is basically you take a chunk of semi-valid data or semi-random data and you feed it to an application. And with semi-random or semi-valid data, I mean that it's good enough so that the application thinks that it's data that it can parse. For example, if you've got a file which has a magic number and that magic number isn't there, the parser will say, oh, there's no magic number, it's not my file, I'm not going to parse it. But if that magic number is there, it'll be like, oh, this is my file, and I'll parse it, and if you're lucky, it'll break on something. So that's basically what I mean with semi-random or semi-valid data. The other thing which kind of amazes me with fuzzing is if you usually talk to people about fuzzing, the first thing that comes to mind is let's fuzz HTTP. So the thing is that HTTP has been fuzzed to death, basically. There's lots of other things that you can fuzz. Basically, anything that takes any kind of input, any electronic device that takes input can be fuzzed. So some of the things that you can fuzz are network protocols, network stacks, anything that SUIT takes, arguments, standard input, environment variables, file descriptors, signals, all sorts of cool stuff. You can fuzz APIs, system calls, and I'll be talking about that later. And you can also fuzz library calls. And you can also fuzz files, and I'll also talk about that later on. The thing about fuzz is that they're amazingly cool. It's kind of hard to describe fuzzers. You really have to try some of those and see how cool it is to break stuff with doing very little. Right, so this is kind of a quick thing I made which shows you some of the things that you can use to fuzz in a SUIT binary. So, most people think of arguments and some think of environment variables, and that's about where it ends. You've got a lot of other things that you can use to fuzz. You've got signals, file descriptors, current working directory, shared memory, TTY, timers, all sorts of stuff. Right. So, the kind of fuzzers that people use. First of all, you've got manual testing, which isn't really fuzzing. It's kind of usually preparing to fuzz. What you do is you observe the data being exchanged between client and server, for example, or what a file format looks like, change a few things, run it through whatever it has to parse it, and see if it will parse it or not. And you'll try to look for interesting stuff, size fields, things that might look like strings, and a few other things. Then you try to change that data and see what happens. It's usually preparation for fuzzing. But it's not uncommon that while you're doing this, you'll already find 1 or 2 bugs. The second kind of fuzzing is semi-automatic fuzzing, which is basically where you've done manual testing and you'll have a script which does these things, and you'll do one test run of your script and then examine what's happened. And this is interesting because you can use semi-automatic fuzzing to notice very subtle bugs, things that you would normally not find or not notice with automated fuzzing. Information leaks are a great example of that. They're usually, you usually can't find it with automated fuzzing, but with semi-automatic fuzzing, those are some of the things that you should look at. And then what most of my talk will be about is automatic fuzzing. And this is basically where you have a script or a program which iterates over a very, very big loop. And this can be an endless loop, and just tries to spit out all sorts of semi-valid or semi-random data. And you just wait till something crashes or it hangs or it reboots or whatever. Right, so more specifically, the tools that you'll want to use for fuzzing. Fuzzers, they're made by people, obviously. The first one is fuzzing tools. They'll fuzz one particular protocol or one particular file or maybe something that very narrowly fuzzes one particular system call, something like that. The other one are fuzzing frameworks, and those are more interesting because they're written usually some kind of scripting languages, and they don't fuzz on themselves, but they give you very, very useful APIs to fuzz stuff. They'll do MD5 checksums and CRC32, and they can do compression and URL encoding and decoding, and all of these cool things that you no longer have to implement. So that means you get to write your fuzzers or your fuzzing scripts a lot faster than you would if you would write your own tool. Most of these fuzzing frameworks these days, they come with default scripts, and lots of those scripts are usually very cool. I mean, if it worked against one product and it's never been tested yet against another product, if you run against the other product, chances are you'll find a couple of bugs. Most of the frameworks are specifically focused towards network fuzzing, but there's one, at least, Peach, which I'll be talking about later, which does more than just network fuzzing. It can do file fuzzing and API fuzzing and all the things I just summed up a slide ago. And the thing about these fuzzing frameworks is that, well, I mean, they've got a learning curve because you need to know the API, and if it's a language you don't know, you'll want to learn at least the basics of that language. So there's a learning curve. So, having said that, let's move on to some of the cool tools that you can use to fuzz things. The first one is Protos. This one's developed at the University of Oulu. It was initially developed in '99 until 2001, and some other people, 2002, 2003, picked it up again, and then somewhere this year, somebody picked it up again, and they developed an IPsec fuzzer, well, some of the IPsec stuff, and pretty much lots of people were vulnerable again. So this is sort of, I guess, actively ongoing, and they developed just one tool, and then which will very precisely fuzz the protocol in great, very deep detail. One of their most known fuzzers are the SIP fuzzers and SNMP. Unfortunately, the thing's written in Java. I'm not a big fan of Java, so, but it's still really cool. You should definitely check out their website. It's pretty awesome. Yeah, so I don't know if you could all read this, but if you reach slides later, you can look over it. These are just this is scratching the surface. This is just some of the stuff that Protos broke. It's broken like 1,000 different things. One of the things why people might remember Protos is because I think in 2001 or 2002 they exposed what I call the big SNMP fuck up, where basically everybody who implemented SNMP based their code on some old SNMP code, and they were all vulnerable to the same bug. So that was kind of bad, and that's one of the things that Protos found. The guys who initially developed Protos started a company called Codenomicon, and they've got a whole range of fuzzers, or test suits, which is what they call it, and they're used for commercial companies. It's basically sort of the same approach as Protos, at least from what I've heard, where they go in very deep detail for every protocol and have a large set of test cases that they can run. I've been told that those products are not really cheap, so if you're not a big company, you probably cannot afford those tools. Right, so even more Protos stuff. Even today, you can use Protos against some SIP stuff, for example, and find some really neat stuff. So one of the things that a friend of mine has looked at is a hammer call analyzer, which is a sniffer specifically designed for SIP interpretation. And he found a neat bug in there where you can write a 0 byte anywhere. The guy who found it is called Kokanin, which is his nickname. For those of you who might know him on something else, he's the hacker that got PH neutralized. So this is the hammer call analyzer, and if you just run Protos against it, you get this, and this is the old famous pop-up in Windows saying, your program crashed, and do you want to report this to us or not? I actually don't understand all of that because this was done on a German box, and I'm pretty bad at German. But everybody should be able to recognize the pop-up window you get if stuff crashes. Right, and if you look at it with a debugger, I don't know if you can see it, but underneath there it says access violation when writing to an address. And basically you control that address. And if you look, yeah, probably can't see it above, but it's a move instruction where you write a 0 byte to anywhere you want to. So this is a bug that got found with Protoss. And here's my 0-day giveaway for today. This is the proof of concept that Kokanin made to trigger this bug. And it's a very small Perl script, and this will exactly tell you where the bug is, and if you want to write a cool exploit for it, this is a really good starting point. Right, so moving on to the next fuzzing fuzzer. This is Smudge. It's a fuzzing framework which is written in Python by a friend of mine, Andy. Yeah, Smudge stands for Software Mutuation Utility and Data Generation Engine. It has support for a lot of protocols. Unfortunately, it only does network fuzzing, so you can't do anything else with it. Some of the test cases it uses were taken from Spike, which is something I'll cover in the next couple of slides. So yeah, Smudge is pretty cool. Unfortunately, it's unmaintained, so it's kind of hard to, because it's got some bugs in there, so it's kind of, if you don't know it that well, it's kind of hard to work with it. But it's pretty cool though. You can find lots of cool stuff with it. For example, it broke subversion, shoutcast, some IRC daemons, a bug in mod security, and a whole range of other stuff. Right, so this is the subversion bug, which is basically you get control over several registers. And then the one where it breaks now is basically a read from an address you can control. In the bottom you can see 3F, 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 which is an address you control. And later on down that code path, you can actually write to some of the addresses you control. So this one's a pretty neat bug. Right, so that was Smudge. Yeah, okay, moving on to Spike, which is a fuzzing framework, which is written in C. It's written by Dave Eitel. It comes with a lot of default fuzzing tools for anything you can imagine. You know, the Oracle TNS listener. It's got support for lots of like remote RDP for Windows, a Gopher daemon, and a whole range of other cool things. Spike is a huge tool. It's really cool. It's what Dave Eitel called, it uses block-based fuzzing, which means that if you've got a protocol, you can split it up in several blocks and then start fuzzing from a specific block. Most people say that Spike doesn't have that many documentation. I think it actually has a fair amount of documentation. It's got some slides that Dave has, a paper, and a whole lot of fuzzing tools and fuzzing scripts in there that you can just look at and see what it does and just learn from it. Unfortunately, Spike, again, only does network fuzzing. Yeah, it kind of sucks, but, well. Then there's Spike file, which is sort of like Spike. Basically, it's Spike 2.9, and it's a modification which Adam Green from iDefense made. And basically, all the network stuff got ripped out and got replaced with codes to fuzz files, which is interesting because you get the same scripting language that Spike has, but now you can not only fuzz networks, but you can also fuzz files. So some stuff that Spike broke. It broke a lot of stuff. You know, the list is here. The interesting thing about Spike is that like some of the scripts are kind of broken. Like Dave Eitel, at least I'm guessing, probably broke them a little bit so that 0-day he found doesn't get exposed. And on his mailing list, there's a guy, Andy, who made a comment about it, saying he recommends to use Spike. You know, although it's written in C and it appears to be broken on purpose, you know, it's really cool to use and find cool bugs with it. So, right. I was actually going to do a demo of Spike with the Gopher fuzzing and show you that if you make some slight modifications, you find cool bugs in Internet Explorer. But unfortunately, because it's the Internet Explorer for macOS, unfortunately I don't have a Mac with me, so I couldn't do it. But the code can be found on my website, and if you have a Mac and you try it against your Mac, I i.e. on Mac, you'll find a heap overflow in there. So, how to start with Spike? Basically, Spike is as a sort of a scripting language, and the way you usually start with, if you got an unknown protocol, is you sniff it, and then just take the binary dump you get from Ethereal and use the S binary. And then you start looking through the binary code and see if you can recognize some integers or string fields or whatever. And you replace them with calls like S-word and XDR string, and it's got like a whole range of other functions as well. And then, you find the lengths, and you mark the blocks beginning and end, and then, try to see if it still works, because if it doesn't, you kind of fucked up somewhere. Right, that's basically how you do it. You can just, you can just call a loop there, and then start fuzzing and just let it run until something breaks. This is basically a slide I took from Dave Vitale's presentation at Black Hat a couple of years ago, because this is the essential stuff you need to start with Spike. Right, this is another thing. A guy called Tom Ferris made a small Spike script for RDP, which is the Remote Desktop Protocol for Windows. And he ran it against Windows and got a cool bug out of it. And the very interesting part is that Windows XP Service Pack 2 comes with a firewall, which is on by default, and it's got everything, all incoming stuff filtered, with the exception of RDP. So that's kind of, even though the firewall's on, it's filtering almost everything, you can still do a denial of service against the Windows box with this. Right. Yeah, the other thing is Spike by default does not work on macOS. I wanted to get it to work on my macOS and came to the conclusion that most of the code, pretty much all of the code, works on macOS. Because it was initially written for Linux, and so far it only compiles on Linux. And the only thing that you have to do if you want to get it to work on macOS is change some of the arguments to the linker, and then change the LD library path to dy LD library path, and comment out LDL RPC. And then Spike just compiles on macOS, and you can do whatever you want to do with Spike on macOS, and you're not just restricted to using Linux. Right, so that was Spike. The next fuzzing framework is Peach. It's written in Python. It's written by a guy called Michael Eddington. He developed it during PH Tutorial, I think last year or the year before. Most people are very lyric about it and say that the documentation is so wonderful. I don't really agree there. I mean, there's a lot of documentation, but it's all auto-generated from comments inside the code. And the thing with comments inside code for documentation is that if you're not very well aware that it's comment for documentation, and you don't put a lot of effort and thought into it, it's more comments that document your code and aren't exceptionally useful if you don't have the code sitting right next to your comments. So that's why I don't really like the documentation in Peach. The other thing that annoys me a little bit about Peach is that it's got a whole range of APIs to generate a lot of cool things, but like a lot of the APIs are there to generate valid data. It can do URL encoding, it can do encryption, compression, checksumming, all sorts of these things, but it does all valid stuff, and because it's a fuzzer, you want to create invalid data. So, I mean, obviously it's got some APIs in there to create invalid data, the normal stuff, strings and integers and stuff. But the cooler things, like compression and URL encoding and stuff like that, there are no hooks to create malformed data. So that's kind of the thing I miss in Peach. Besides that, it's a wonderful fuzzing framework. The difference between Peach and the other ones I covered is that Peach does a lot more than just network fuzzing. It can fuzz APIs, it can fuzz files, it can fuzz COM objects, it can fuzz pretty much anything. Recently, Michael Eddington released Peach.net and Peach.c, which you can use to fuzz .NET stuff, and you fuzz anything written in all APIs from C. Right, I don't have a slide of stuff I broke, because apparently people aren't keen on telling the world what some of the things they found with Peach. It's a cool framework, though. You should definitely check it out. Right, this is the documentation from Peach. But yeah, so it's all auto-generated. I'm not a big fan of this documentation, so maybe some people are, but I don't like it that much. Right. This is one of the sample scripts in Peach. Basically, this is a sample script to show you how you can do COM object fuzzing. So yeah, if you read documentation, all of this makes sense. Yeah, or if you read documentation and toy with it a bit, it makes sense, right? The next fuzzing framework that I want to cover is the protocol independent fuzzer, which is written by a guy called Matthew Franz. It's not a fuzzing framework, unfortunately, and this really sucks. It's not available to the public. I've never used it either, but Matthew Franz in 2004 made a presentation for Black Hat talking about doing some examining the security of BGP and how it's implemented in several routers. And throughout the slides, you'll see a lot of cool things that he does with his fuzzer, and he'll go into some detail of how the fuzzer works, but it's never been released. And so I emailed him about it, said, is it ever going to be released? And he said, he would have loved to, but Cisco management didn't like it. So unless you work for Cisco, you're not going to see this tool ever, unfortunately. From the slides, it says that it found 4 or 5 BGP-specific implementation bugs. So that's pretty neat. Yeah. So the next one is the Mangle Me fuzzer. Right. This is written by Michał Zalewski, and this was done somewhere last year, and probably everyone knows it because it got slashed out. Basically what it does is it generates something that looks like HTML, but it's very, very broken. The code itself is pretty clean. The Mangle Me code, it's easy to extend it. He's got a demonstration of Mangle Me code on his website, which is mangle2.cgi. Actually, you're supposed to go to mangle.cgi, which doesn't do anything, but it gives you a big honking warning saying, if you proceed, things might go very wrong, files might get deleted, your box might crash and whatnot. And then Mangle2 is the actual tool which gives you a demonstration, which just start fuzzing your browser. And if you're unlucky, or if you're lucky, I don't know, your browser will break. So the things that Mangle Me broke were like pretty much all browsers that ever existed broke on it. Yeah. And then Andy made a port to Python, and he changed a few things, and he made it a little bit smarter than Mangle Me was. And so a few minor modifications, and he fuzzed the now very famous iframe bug in IE, and then led to some worm. The thing with these tools is that they're just scratching the surface. There's so much more that you can do with browser fuzzing. And also just the HTML part, what Michał Zalewski did is he took the most common tags and most common attributes and started fuzzing those. I made a modified version where I just took the HTML4 specification and it put all the tags in there and all the attributes. And if you run it again, you get some new bugs in IE, some new bugs in Firefox, and pretty much all browsers out there. You can find that tool, which is basically an extension of HTMLer, on my website. There's a link to it at the end of the slides, and I'll give a slight demonstration of some of the things I've generated, and you'll see Firefox die in a couple of minutes. Right, but first, so some more stuff about HTMLer. This is so Andy fuzzed the thing, and he posted it to, I think, full disclosure. And then Skyline examined it and said, basically you get to smash an instruction pointer. Okay, so that's code execution, obviously. Right, let's see. This is Firefox. And because, I've generated these before, because if you generate them, sometimes it takes a while to hit something that breaks. But this is what the new, so this is, so this is, you can see this 107, which is not the latest one anymore, but it was a couple of weeks ago, because I think 1.5 is released these days. So, but this one's a pretty recent one, so all the bugs that were found with the Mangle Me fuzzer, they were fixed. So this is the extension I made to HTMLer, and I think this one should. Give it a second. Yep. And voila, there. And it basically crashed, and you can send stuff to Mozilla. I think this one's a no-pointer reference, but there's another one in there where you get to smash a function pointer. Yeah, some basic details in there. basically the stuff you need to see what's going on. If you make some small modifications to HTML, you can still find new bugs that, oh, bug. I'm not network connected, so. You don't want to give people your bugs before you got a cool exploit, The next tool is Mangle, which is a very, very small piece of code that I made, about a year ago. And it's only 60 lines of C code. And what it does is it takes a file and you give it a header size, like let's say it's a page long. And what it'll do is it'll take 10% of the header size and then use that in a loop and then randomly choose an offset inside header and just randomly change a byte and have that byte biased towards the highest bit set because you want to try and trigger some sinus bugs, things like that. This is basically the kind of Unix way that I did it. To keep it simple, because in order to effectively do things, you'll have to use a bash script to have a loop and stuff like that. Right, and these are some of the things that I found with it, and I'll give you a demonstration of some PHP bugs. Basically, because my original Mangle tool is not the one I'm going to use, but I made a port to Python where it generates HTML as well, and then just points the HTML to an image file, which I used Mangle on. And right. Should be one of these. Nope. Right. So this is the test.php is basically it's going through all the stuff I've made with the Mangle tool. And then if you, so this is the little script there. If you can read PHP, or even if you can't read PHP, it's fairly trivial code. So basically it goes over a range of files and sees if they're JPEG files with EXIF data in it, it'll try to parse them. And if you run it now, just wait a second. Well, right there, possible integer overflow, and the process stopped. So, and the EXIF code in PHP isn't that wonderful. You've got a couple of other very nasty stuff in there. Right. So that's, but really, the Mangle tool really kind of took me by surprise because it's the most trivial thing you can ever imagine, and like everything breaks on it. Right. So this is some of the things I fuzzed with it, and some of the images you get, and some kernel oopses and segfaults, stuff like that. Right. Another one I made is a very, very small system call fuzzer. System calls are basically, if you don't know what system calls are, they're basically a service that your kernel provides to you, and you can just tell your kernel, I want to do that service, and give it some arguments, and if your arguments are valid and you're allowed to do that system call, the kernel will do that for you. Oops, damn. What I've done basically is I've generated random system calls and then given it random arguments, like pointers that point to kernel space, or invalid pointers, null pointers, or pointer to some data where I put to some piece of memory where I've put random data, stuff from def random. And I just fed it to the kernel. And obviously, there are some system calls that you want to ignore because they interfere with fuzzing. Exit's obviously one. You don't want your fuzzer to stop. You want it to continue until you get a kernel panic. Some others are fork because it's very annoying when you've got a fork bomb while you're fuzzing. And there are a couple more. You got some things in there that sleep indefinitely, things like that. So you want to have a list of things that you don't want to fuzz, and besides that, everything else is fine. So usually this results in a kernel panic or on Linux an oops message. And I think, yeah. So it broke SCA Unixware, and I'll give you a demo of this in about 2 minutes. It breaks, easily, and the panic's kind of neat though. And then macOS obviously broke because macOS breaks and everything. Right, so this is, I'll show you this in real time, but I'll do that first because that's cooler. Right, so this is SCA Unixware. you know, and this is my system call fuzzer. Just let it run, and bam, that's a kernel panic. You know, the kind of, the ping kind of thing there, that's a kernel panic. You know, my mouse is no longer moving, it's dead. So, okay. I'm done with this, because I'm going to close VMware, because it's a huge strain on resources. Okay, so. So this is what you guys just saw. You know, you get a normal Unix and you're working on it and you're doing stuff, and bam, it goes down. Oops, something went wrong. And here's another cool thing. When I rebooted the VMware, you know, it gave me a core dump of the kernel. You know, do you want to save this core dump? And I'm like, of course I want to save it. Do you want to compress it? No, because I have enough disk space. Do you want to encrypt it? Yes, because I don't want other evil hackers to see the things I've done. And then you go like, okay, so enter your encryption key, and obviously there's an evil hacker standing behind me, so I don't want him to see my key. But then, you know, my key's there in plain text. You know, so it kind of makes no sense to give an encryption key and then just put it on your screen like, hi, I'm an encryption key. Right. So another really cool thing, a very small fuzzer is what the guys from Ethereal developed, because I don't know if you guys have looked at Ethereal over the years, but you know they've spit out a lot of advisories. You know, the advisories kept growing exponentially. You know, in 2001 it was like 1 or 2 issues, and at the beginning of this year there were like 50 issues in one advisory. So one of what the guys at Ethereal did is they said, well, you know, we don't want to have this kind of bad record, so they made their own little fuzzing tool, and they used editcap, which is a tool they've made. And they made a small shell script around it, which does some statistics and tells you some things that editcap wouldn't. And it's written by the guy who made Ethereal, Gerald Gomes. And today, I think they fuzz more than 600 bugs in Ethereal. That's kind of impressive. You know, the usual stuff: overflows, endless loops, no point references, division by 0, and a lot of other things. And what's interesting is, and I don't think anybody's ever done that before, or at least not talked about it, is that basically what this tool does, it takes a PCAP file, which is a almost raw file of network data coming through with some metadata in it. And it takes a PCAP file, and it just searches for stuff and changes bytes, you know, puts format string bucks in there, and, you know, FFFFF and things like that. And then just feeds it to Ethereal, this PCAP file, because Ethereal comparses PCAP files. And if Ethereal breaks, they just fuzz the bug with this thing. So you don't even need network connectivity, you just need a good PCAP file, and bam. And the cool thing is, TCP dump can also parse PCAP files. So you could just take this fuzzer, and the only thing you'd have to change is the name of the program you want to call, which is, instead of tetherreals, now TCP dump, and just let it parse that file. And I'm guessing that if you would do that on TCP dump, you'd easily get lots of bugs, because TCP dump is not written with security in mind. Right. So, and this is one of their advisories, May or June or something, and this is some of the stuff they found with their fuzz tool. You know, they're freeing uninitialized variables and infinite loops, and you know, trivial stack smashes, all sorts of very nasty stuff. Another fuzzing framework, which is called BED. I've forgotten what it stands for though. But it's a fuzzing framework which is written in Perl. It's got some cool scripts, and it has a very, very simple way to make scripts for it. Basically, the scripts you write for BED are also written in Perl, and it's got some, well, I'll show you in the next slide, some really cool, easy things in there, which makes sense. So, right, so next slide after that, that is. Some of the things it broke, basically some web servers and FTP servers on Windows. Nothing that big, but it's a nice framework. It's a smaller one, so it doesn't have lots of APIs or lots of cool scripts, but it's an interesting one. Right. So this is what plugins for BED look like, where you got initialize, how to quit, do pre-out stuff, do stuff after authentication, how to do authentication, these kinds of things. So BED's only made for network fuzzing either. but I like the way they've organized things. Right, so here's another small thing I've made, which is called IRC fuzz. And basically what IRC fuzz is it's a very small fake IRC daemon. And when somebody connects, it'll just spit out something that looks like IRC, but it's really not, and it's just designed to try and break your IRC client. And basically, with the exception of IRC, all of the clients I tried broke. Nothing survived. And right, oh, I'm not going to show this one yet because I'm going to demonstrate it first. I have it here. Right, so I've got the IRC fuzzer already running. I'm going to do it in full screen. I've got it running, and I've got it in a debugger attached, or I'm going to run it through the debugger so that you can see things that go wrong. And you run it, and it connects to it, bam, it dies. And you run it again, it dies again. So it's got like lots and lots, 4 or 5 bugs that easily pop up. We've got 3 different bugs right now, and I think my bug count right now is like 15 or 16. So lots of things in there. Obviously, this shows that IRC2 was written in another area, another period of time, and it's not up to standards these days anymore. The guys who wrote it didn't have a clue what security was, and what the fuck is bound checking, and what's kind of, which I'll show in one of my slides. Right. So the next slide is, so this is basically one of the stack smashes you saw there. And one of the stack smashes is kind of cool because it's just a message that you're sending. So it's bigger than 512, so you would assume that servers don't allow it through, which is true, which they don't. But because it's just a simple message, you can do a DCC chat, and when people accept it, you can just, basically, if you want to own them with that, you can just do it client-side. You don't need to have an evil server for that. So this is one of the stack smashes you saw. And I've got a friend of mine whose nickname's JDuck, and he's got an IRC client, which is based upon IRC2. It's called Ninja. So I sent him my fuzzer and say, try it and see what happens. And because this client was based on IRC2, most of the bugs in IRC2 showed up in his client as well. So he fixed them, and he sent an email to the guy who's responsible for maintaining IRC2. And he got an email back from the guy saying, oh yes, I know about that bug, we're just not going to fix it. So I don't really remember the reason why, but I think it's kind of odd that if you've got this amount of things, which you can easily fix, you've just seen it, just bug after bug after bug, just right then and there. So this is pretty bad, and I don't know why the guy hasn't fixed it or doesn't want to fix it, but he should. So right, so that's IRC fuzz. It's kind of, a funny thing. Next one's ISIC. This one's a bit older, I think in the 90s, maybe 98 or something. And it's basically an IP stack integrity checker. It's not called a fuzzing tool, because back then people weren't calling things fuzzing tools, but it is a fuzzing tool. It's written in C. It's written by a guy called Mike Franze. Basically, it generates IP, TCP, UDP, and I think even ICMP data, which is flawed. It looks like it, but it's really not that kind of data. And then, it's got some cool stuff in there. It's like may break shit, melt your network, knock out your firewall, or sing the fur of your cat. So it's a pretty cool thing. And if you see the next slide, it's broken a lot of very high-profile stuff. You don't want your firewall all of a sudden quitting. That's kind of bad. And a few other things, and probably if you run it against some other things these days, you'll probably find cool things. Right, so that's ISIC. Right. The next one's Combust. This is written by a guy at Stake, written it. I guess it's Symantec now. He did a talk about this with Black Hat, and he showed how to use it, and I've kind of played with it for one day. And I installed my XP Service Pack 2, a fresh install. I did a complete upgrade, and this was like back in June or something. And you're playing with it one night, I came up with about 15 bugs. Some of those things can be triggered through Internet Explorer, which I'll show in the next. Show some of the screenshots on the next page. So you find a shocking amount of stuff in things that people are running today, which is, with the latest security patches and things like that. One of the things that it doesn't do is it doesn't enumerate over all the COM objects you have in Windows. So you just go to Microsoft.com, you look for this tool called Oily View, and so this one, and download it, and this will give you an overview of all the registered COM objects on your Windows box. And you've got to find COM objects that have the iDispatch method, because otherwise you can't fuzz them with Combust. But you find a lot of stuff with it, and so this is the first thing. And basically, what you see above here is the OLA View tool from Microsoft. And what you see here is, Combust. And basically, what you do is you say, give me the class ID of that COM object, and it'll just see all the methods that it exports and that you can use, and it'll try to fuzz all of them. And Combust has a fairly big configuration file. So a lot of the things in Combust can be modified. Like if you want to overflow with not A's or B's, and you don't want strings to be 5,000 lines of code, 5,000 characters long, but 7,000, then that's okay. However, if you make the lines that you want to fuzz with bigger than 15,000 lines of A's or B's or whatever, Combust will crash. So yeah, guess there's a bug in Combust as well. And then I've got another screenshot with some other stuff. So basically, what it does is it tries to fuzz all the integers and long strings and things like that into all the methods that a COM object has that it can get its hands on. And then whenever any kind of exception occurs, it'll just catch it and say crash. And if you want to see what's actually going on, you have to attach a debugger, and I'll talk about those kind of things later. Most of those COM objects are not exceptionally useful anymore with IE, because these days most of the COM objects have the kill bit set in Windows. You can no longer reach them from IE unless the guy sitting in front of it clicks on OK 3 times, which I guess is pretty much okay, because most people on Windows do that anyway. They don't read their messages anymore. Just OK, just let me continue. But you can't just do it. You need user interaction. But some of these are kind of nasty. I think there's some heap overflows in there, but they're mostly no-point references, though. Right, so, the other thing that I want to say about Combust is that it's binary only. So it's got a lot of features. It's, does a lot of cool things that you want it to do, and it's very configurable, but it's binary. You can't extend it. If it's missing some very specific part that you want to do, that you can't do, it's binary only, so. Unless you're a really good reverse engineer and you can put binary code in there, you can still extend it, but that's a lot of work. You might just as well write something from scratch, which somebody did. And it's basically the same thing as Combust. It's open source, but it lacks a lot of the feature that Combust has. Combust really is very, very configurable. This one is not, but it's open source, so if you want to have these features in there, you can just hack on it. It's written by a guy called Shane Hart. I don't know how to pronounce his last name. Hirt? I don't know. I haven't spoken with him, so. But it looks promising. I haven't actually toyed around with it much, but the things that I did see is that it's more limited than Combust right now, or at least when I looked at it. That was a couple of months ago, so they might have added more stuff in there. I don't know. Right. So the next tool is Fuzz Server, which is written by another guy from @stake or Symantec, which basically is a web client or a gateway fuzzer. And it's also written in C. It's open source. I think it's made for Windows, but it might also work on Linux. Right. And this is because it's got like cool ASCII stuff in there explaining how it works. And basically, you've got your web client and your web proxy and your fuzz server, so you send a request, and basically what a fuzz server does is it does very trivial HTTP or WDP fuzzing. I guess the kind of fuzz sets are somewhat outdated for these days. I've been told by a couple of people that this tool used to be used a lot, so I included it. I haven't played around with it much though. Right. oh, this one's really cool. This one got me, I missed a couple nights of sleep with this tool. This is a kernel stress test tool developed by a FreeBSD kernel developer. And it's amazingly cool. It fuzzes a lot of things. It does syscall fuzzing. It does socket fuzzing. It does some very cool stuff with your swap files. And one of the cool things about this tool is that the essence of the tool is chaos. The more chaos, the better. And the other thing is that it requires or tries to get low memory conditions. So the less memory you have, the better it is to fuzz with stress too. So if you're running FreeBSD in VMware, change the RAM to, I don't know, a gig to 8 megabytes or something. And all of a sudden, you'll find lots and lots of bugs. As a stress test tool, and one of the cool things in there is, in the make file, it's big honking warning. Do not run it as root, because lots of stuff will happen. Most likely, you won't be able to reboot anymore. But if you go to his website, you get a large list, because this one looks pretty small, but he kept updating it. So, because this one was done in, this list from August, and I think the last update was from a week ago. So all the things he finds with his fuzzer, they get up there. And if you go to that website there, and you click on console log, you get an entire stack dump and some more. You get the registers and things like that. So you get to see all the things that are wrong, and that's pretty cool about it. And every once in a while, some of the stuff he finds, because every once in a while he adds some stuff to his fuzzer, because he tries to fuzz specific areas of the kernel. And so every once in a while he adds stuff, and I don't know, no, I didn't. One of the things he didn't add in there, or at least I thought he didn't, was a fuzzer which fuzzes ELF files. If you load an ELF file, your kernel has to parse it, and there's a lot of data in there to parse, a lot of ways that things can really go wrong. And I had done some very dumb fuzzing with the Mangle tool, which I described earlier, and I'd run it on FreeBSD as well, and I came across some things that FreeBSD kernel shouldn't do. And I mailed him about it, you should maybe have some similar stuff in there. And he mailed me back and he said, yes, actually I do have it in there, but I can't put it out yet because the security guys are looking at it and we're trying to fix it. So, the tool has got some things that aren't public yet, but it's a really cool one. And basically, because they just keep finding new stuff with it, just keep running it. I think the latest one a couple of weeks ago was in the FreeBSD 6, the one that got just released. Yeah, so some bugs were found in there. And I think they're even doing it on FreeBSD 7 these days. Right, so Stress2 is a really, really cool tool. And if you ever get the chance to play with it, you definitely should. And did I mention? No, I didn't mention that yet. A friend of mine actually made a port of Stress2 to macOS. Because macOS is basically the kernel is large parts of the kernel are FreeBSD. So also most of the syscalls are FreeBSD system calls. So with minor modifications, this tool will work on macOS. Right. I don't have his email address somewhere on there, but if you want the tool, come up to me later and I'll give you his email address. Right. So this is Stress2. And then the next one's Bugger. And this one's actually neat because it's sort of a new approach to fuzzing. Basically, it's written by Michal Zalewski. And basically it uses pretrace to fuzz. And what it does is, because what Michal Zalewski has is, if you got large commercial tools, they'll use encryption and checksums and compression and all sorts of things that you really don't want to build fuzzers for because it takes days or weeks to do that. And so what he did is he said, well, why not just change the client into a fuzzer? So he has, I think, about 500 lines of C code or something, code which attaches to your normal client and then just makes subtle changes to the data you're going to send to your server before it gets encrypted, before it gets compressed, and before any checksumming is done. So this makes it a lot easier. And it's a proof of concept because it's really not that big, but I think it has an enormous amount of potential. I think this is one of the things that people should really look at in the future for fuzzing, because I mean it's pretty neat. Right, that's Bugger. The next one is Shredder, which is basically there was a company called Rapid7 Security, And a couple of years ago, they made an SSH fuzzer. And it just does pre-key exchange stuff, so only phase 1 things. And basically, they found a whole range of things in a whole range of products. And they didn't release their tool because it's a commercial one, but they did release 666 files of all the different kind of bugs they have. So what I did is I made a Perl script, or yeah, mine's a Perl script, which is sort of a small fake SSH daemon. And it just takes one of these files and runs the mangle tool over it. So it takes a somewhat semi-valid SSH file which has already been used to fuzz stuff, and it just subtly just changes bytes in there. It does it. It's very dumb fuzzing, but you get some results with it. So you don't get their tools, but you get you get their files. The things you get their data. So that's good enough. You can build a tool around their data. And basically in their advisory, some of the things it does is some packet lengths, string lengths, and some padding. So basically all the things before the key exchange stuff, they try to fuzz. They've released those the data for that. And if you see the list of stuff they've broken, it's a fair amount of stuff. Not surprisingly, OpenSSH is not on there, because it was, despite the fact that it has had some security bugs, it was actually written with a lot of security in mind. So, but there's the stuff in there, is the some of the things you see advisories for every once in a while. To put the SSH client and F-secure SSH server and all sorts of things. But OpenSSH is not in there. I'm guessing if you would make a very detailed SSH fuzzer which covers almost the entire code paths, and you put a lot of tests in there and things like that, you might be able to trigger something in OpenSSH, but that would be a huge time investment. But if someone is up for that, that would be really cool. Right, so sfuzz, which is another small fuzzing tool I made. Basically, it's sort of an extension of my system call fuzzer. What it does is it takes a group of system calls. In this case, anything that creates sockets. And then you create a socket, and you randomly give it a protocol and a family, and what's the argument? I forgot. Basically, so you fill in the 3 arguments of the socket function randomly, and when you get an invalid socket, you just go back to your loop. When you get a valid socket, you just do random socket operations on that socket. And one of the things is, if you're going to try this, you have to watch out, because you also get Unix domain sockets, and they tend to is it domain sockets? Yes, I think so. Yes, they tend to create files, and if you run this thing a lot, let's say you give it 1 million operations, you get 1 million files. So that's kind of annoying. And these are because it's files with random names, so it's kind of annoying to delete all of them. I've been there, accidentally deleted some other stuff that I didn't need. And one of the things I did is it fuzzed 2 bugs in the Linux kernel, which I will demonstrate. Don't need those anymore. Right, yes, so this is it, sfuzz. And one of the reasons, actually the only reason why I'm running sfuzz in GDB is because I have a bug in there somewhere. I haven't figured out where yet, but if I don't run it in a debugger, it goes dog slow. If I run it in a debugger, it goes normally. I don't know why, but for some reason it does that. I mean, if you want, I can demonstrate it. This is, right, so, this is, it's still looking for the first socket. This is the first one. So this is dog slow, but if I do it in a debugger, bam, well, okay, it's already fuzzed the bug in the kernel. But let me show you again. Right, so it goes a lot faster, right? So it's got a bug in the kernel, and if you check the oops message, you have a null pointer reference in the Bluetooth stack. Yeah, it doesn't say Bluetooth stack here, but if you check it, Yeah, okay, give me a sec. Huh, break. Yeah, so you can see right here that it's in the Bluetooth stack, because socket in the 31, that's the, I think, that's the one that says, hi, I'm Bluetooth. So this is definitely a bug in the Bluetooth stack. Right, so that was sfuzz. All right, so this is, I think the one you guys just saw. Oops. And this is pretty annoying. I keep hitting it with my foot. Right, so this is the bug in the Bluetooth stack. Right. And another thing I made is called DHCP fuzz, which sends out very bogus DHCP messages. And I also have a demonstration of this, but it broke TCP dump in verbose mode. Basically, it's sort of a denial of service. Sometimes, certain type of packages, TCP dump takes 2 or 3 minutes to parse a single packet, which gives you a huge things of packets it can't parse right now. And if you send out a lot of those packets, TCP dump will pretty much do nothing. The other tool is DHCP dump, which is apparently used a lot by some administrators. It's got null point references, stack smashes, endless loops, lots of stuff in there, and I'll demonstrate that. Don't need this one anymore. Don't need this one either. Only 3 of them left, so that's good. Right, so already have this running. The thing you see here, this is DHCP dump. This is my debugger attached to it, and this is my fuzzing script. The reason why I'm doing preloading here is because I'm using net packeting Perl, and that library, that library has a call to sleep in there. So it's kind of annoying to only fire out 1 packet every second. So I'm preloading sleep to instead of sleeping for a second, sleeping for 1/10 of a second. And if you do this, and it keeps running, and if you give it 2 seconds or a bit more, it should have already broken. Okay, I hope this is one of the cases where it blows up in my face, because, yeah, okay, so it broke, yes. I'm saved. And this is the last of my demonstration, so I'm happy that none of my demonstrations failed. So this is a bug, and I don't know exactly which one, but let's see if we can figure it out. It's probably a null point reference. No, it's not. Right, okay, this is the stack smash. This is cool. You can't see that's a stack smash because a pointer got overwritten. But if you look at this pointer, it says basically 36, 31, 2A, 31. That, if you translate that to ASCII, it says 62.1. So that's data that, ASCII data that you generated, which in this case went over a pointer. And the instruction pointer also got smashed, but you don't reach that yet because this pointer gets fed to string length. But you can make it point to something that isn't that is valid data, and then basically you get an instruction pointer override. Right. Okay, right on time. Right, so the HTTP fuzz. The last one. Okay. Right. I wanted to do a demonstration for this, but apparently I forgot to prepare that. So if you want to see a demonstration of Scapy later, just grab me and I'll show you some really, really, really neat stuff that you can do with Scapy. Because I was kind of like, when I first saw a talk of Philip Biondi, who's the guy who made Scapy, I was blown away. My world was turned upside down because of the things that you can do with Scapy. Because Scapy on itself deserves, a talk of 2-3 hours on itself. But I'm going to try and convince you guys that Scapy is cool. You can create almost any kind of packet, network packet with Scapy in a single line of code. So that's why Scapy is so amazingly cool. And since a month or 2 ago, Scapy had some new code in there which makes it a fuzzer. And one of the things that's really cool about Scapy is that basically it's got support for 36 protocols or something. And what the fuzzing function does is it just takes the protocol and just goes, randomly through all the arguments. Just, if it's an integer, it'll just put some stuff in there, some random stuff in there, and it's an endless loop. And that kind of gives you potentially complete code coverage of the protocol. Obviously, that's not going to always work because you want to have some things in it. Like if you have a protocol that says, I'm only going to parse version 4 of this protocol, you want to override that particular element in the protocol and say it's version 4. And you can do that with Scapy. Basically, with Scapy, every layer of your network is an object. And your object, you can basically say this element is going to be something that I want it to be. And then just say fuzz. And it'll just fuzz it. And you can, when I was at Bucksec with Philip, he had just implemented the fuzzing stuff, and I was like, why don't you try it against the ISE NTPD, the network time daemon, because it's pretty bad code, and you should probably find stuff in there. So he ran it against, which is, actually I wanted to give a demonstration here, but I didn't prepare for that. He ran it against the ISE NTPD, and not surprisingly, within a couple of seconds, we got a seg fault. Yeah, I really wanted to show you guys a demonstration, but yeah, well. But you should check out Scapy. It is so much more than just a fuzzer. It does really neat stuff. And the other thing is that it's, and I can actually show this, it's really easy to add new protocols. So Scapy doesn't have support for Sun RPC, but if you just do this, now Scapy has support for some basic Sun RPC stuff. So it's exceptionally easy to add protocols to Scapy. And the other thing is, if you're going to have stuff that generates, like checksums and stuff like that, you can easily say this field will need this function to generate CRC2 or some other kind of checksum stuff. So enough about Scapy. I'm kind of in love with Scapy, I guess. It's a really neat tool. Also, I mean, you can do anything with Scapy. Just while I was preparing for my talk, somebody came sitting next to me and he wanted to build a MAC address brute forcer because when you've got port security. And he's like, I don't want to write it in C because it's going to take me a couple of hours and so much code. And I'm like, do it in Scapy. And turns out you can do it in a one-liner. So yeah, this is where I'm kind of done with the first part. There are tons of more fuzzers. It's certainly not a complete list. These are some of the ones that I really like and some of the ones that are publicly known to find lots of cool stuff. But fuzzers they're basically the cool thing these days, and everybody's developing more and new fuzzers and cooler fuzzers. If you want to fuzz something, Google should be your first thing. Go to Google, say, fuzzing, and then the protocol or the file type or the API you want to fuzz. And if you're a bit lucky, you'll find somebody who made a fuzzer for it. If not, you'll have to start from scratch. The other thing is that there are piles and piles of private fuzzers, and more specifically, there are piles and piles of commercial fuzzers. Things that cost 20,000 euros and stuff like that. So I can't afford those, but I've been told by some people that they're really cool. So the second part of my talk, yeah, kind of on schedule. So that's the first thing that should probably come up is, what kind of language, if you're going to write from scratch, what kind of language do you do? And these are just some pointers of things that I've come across. And so feel free to ignore them if you don't think it's true, but these are some of the things that, how I feel about writing fuzzers is that scripting languages usually are a lot better or easier because you can write less code and have the same thing that, you would have in C code. To give you an example and come back to Scapy, is that the Microsoft bug where they had a bug in IP option parsing, and it was a proof of concept code public for that. It was a piece of C code, which was about 150 lines of C code, and in Scapy, that's a single line of code. So, and Scapy is written in Python, by the way, so that's one line of Python code, basically. So scripting languages are really cool, and it goes a lot faster if you write stuff in scripting language, usually. The other thing is obviously that, because scripting languages are generally slow, is that your fuzzing on itself will be slower. And one of the things I've noticed about Python is that it's really slow compared to like Perl or something. But you can optimize Python code, so that's good. Most people also recommend using scripting languages because it's just easier to write stuff. However, one of the things that I've kind of experienced is that these kind of scripting languages, they're really cool if you want to do like ASCII-based protocols and stuff like that. But if you've got stuff where you've got a lot of binary data, it gets kind of messy. I mean, like in Perl and Python, you've got to use pack and things like that. In C, you don't need those things. It's all native in C, basically. So if you're going to do a lot of binary stuff, it's probably not a bad idea to use C. Right. Besides all of that, if you don't like any of the languages and you want to write something in Dylan or Lisp or Smalltalk or whatever, go ahead. You should choose a language that you're comfortable with. But these are just some of the things I've come across. Right. So the other thing is smart fuzzers, or not smart fuzzers. Basically, you've got two kinds of fuzzers. You've got dumb fuzzers and intelligent fuzzers. And the difference is that with a dumb fuzzer is that usually it takes you between a couple of minutes and an hour or so to write one. So there, you can sit down, almost get one immediately, and just start fuzzing. The thing is that with dumb fuzzers, you usually don't know the specifics of a protocol, or don't want to know the specifics of a protocol or a file layout or some API, and you just you look at what's valid and then just change some things in there and pass it on to whatever you want to try to fuzz. That's shockingly effective. Honestly, I mean, like the Mangle stuff, which does pretty much the same thing, really took me by surprise. I never imagined that you could break IE and PHP and pretty much a lot of other stuff with it, but it does work. The one thing is with dumb fuzzers is that if there's going to be compression and encryption and checksums, that you're not going to get far. Building intelligence fuzzer is basically the opposite. You know the protocol and the file layout, and you're going to implement the fuzzing. You're going to implement the encryption and compression and checksums and whatever you need. So building intelligence fuzzers takes a while. Obviously, they'll be able to fuzz a lot more and go a lot deeper in a lot of code paths. So intelligent fuzzers almost always give you better results than dumb fuzzers. So it's kind of a trade-off. I mean, if you just want to go out and find one cool bug, then dumb fuzzers usually will give you good results. If you want to try and get complete code coverage, you probably end up building an intelligent fuzzer and spending a couple of days or weeks or even months developing one. So intelligent fuzzers take a lot longer to write, but they give you an awful lot of things, usually. Right. So some of the things that are interesting to fuzz, binary files, movie stuff, and all, lots of programs that interpret them, QuickTime, Real Player, Media Player, MPlayer, tons of stuff. And those are interesting. Say for executable files, the Mako and ELF and whatnot. Because you can pass those to a kernel, and if they kind of make a crucial mistake there, like let's say they take some link and they cause a heap overflow or whatever, that's a local root and that's a local kernel bug. So those are kind of interesting. Some more like Office documents, like OpenOffice, graphic files, and another neat one is file systems, because for example on Linux you've got like tons and tons of file system support. You've got like, with the exception of ZFS, you've got like JFS and UFS, XFS, Ricer, and about 20 other file systems. And all of these, the kernel has to like parse all these file systems, and there's lots and lots of things in there. When I had used the Mangle tool over RicerFS, when I hit the enter button, I got a kernel panic. So lots of things that you can do there. Not binary files. You can, stuff like XML configuration files, those kind of things. You probably want to have smart fuzzers there, or at least take a known file that's known to be good, and then have something that's somewhat smart that can say, this looks like a string, so I'll change it into something smaller or put %n or whatever in it. But usually you want to have some kind of intelligence when you're going to parse stuff that's not binary. Right. Yeah, more stuff to fuzz. You can fuzz, FTP protocol, obviously HTTP, DHCP, NTP, any protocol you can think of, you can probably fuzz. One of the interesting things about FTP is that you've got a lot of FTP fuzzers out there, but at least it looks to me that they're all exceptionally trivial. They take a list of the commands you can and give in the A and B, and then some, the more advanced FTP fuzzers, they try some globbing bugs and maybe directed traversals, and that's good if you want to find bugs in tutor FTPD or something on Windows, which nobody uses. But if you want to, try and be serious about it and see if you can find some neat stuff in like Pro FTPD or something, you're going to have to look at stuff like race conditions, signal race conditions, because you can cause signals with that, like some timing issues. And nobody's ever looked at that with FTP fuzzing. It kind of amazes me, because my guess is that you're going to find a lot of cool stuff there. Right, so that's network protocols. APIs, system calls, are the obvious one. Graphic libraries are probably the also exceptionally obvious ones, because they're going to be parsing a lot of length fields and stuff like that. And you just got to get it wrong once, and bam, there's a heap overflow there or something. Right. So even more stuff to fuzz. SUID files, which is what I talked about in like the third slide or something. The where you can do like arguments, obviously, environment variables, signals, standard input, and for example, also open a lot of file scriptors, and then open 50,000 files, and then don't close them and call a suite file. And for example, if you do that in Solaris, you open 50,000 files, and you run the ping, you get a seg fault. And if there are any OpenBSD developers in the room, they'll probably go like, yeah, we know those kind of bugs. I hear some people laughing, so some people know what kind of bugs I'm talking about. But basically what happens when opening a lot of files is if you've got select loops and stuff like that, you've got something which is called an FD set array, which is a static array on the stack usually, and it usually can only hold like 1,000 or 2,000 files. Basically it's got 1 bit for every file set. So that means if it's got support for 1,024 files, and you've got 1,025 files open, it'll write 1 bit beyond that array. So those kind of bugs are pretty neat. And like on the BSDs, they fixed most of those. On Linux, they're pretty much not exploitable because of very strict R limits. But stuff like HP Unix and Solaris and a lot of other things, just if you open a lot of file scripts and run suites, 9 chances out of 10 you'll get some very interesting bugs there. So, and you can fuzz those things. I've never seen anybody do it, but that would be really interesting. And pretty much any input suite can take, and it's a lot of stuff, a lot of input. Right. So if you're going to write fuzzing tools, there'll be some things that you want to look at. Okay. Obviously, size fields. You want to look at strings, and then like things that terminate some kind of data, and things that mark its beginning. Right, so let's look at size fields. Obviously, one of the interesting ones is negative values. I'm sure you've all heard of it or seen some of those things, but they do cause a lot of problems. If you give -1 in some stuff, that might cause problems. Some more examples. Stuff around like the boundaries, like where you get integer overflows. Those are usually interesting, like 7FFF and then 08000, some stuff like that. They can cause under-indexing, for example, negative values. They can also cause, if you just do a bound check and you store that stuff in a signed integer, and you check if it's bigger than some array, and then use that value to put in a copy loop, it'll get caused to do an unsigned integer, and very, very bad things happen. The other thing that is sometimes interesting is like if you've got binary protocols where you've got length fields saying the string that's coming is 10 bytes long, and then you've got a string there which is not 10 bytes long, but it's 20 bytes long. And then the program will be like, oh, it's 10 bytes long, that's okay. I'll just use string copy and copy that string into my buffer. So the length feels right, but the string itself is wrong. So these kind of things, somewhat rare, but they do happen. So you should definitely, if you got these kind of protocols, you should look at that. Those things are interesting. The other ones, obviously, large positive numbers. They can cause, if you use them with multiplication, they can cause integer overflows. If they're by themselves unsigned, they can obviously cause integer overflows. Yeah, the last one, which is using very small numbers. And that might sound a bit odd, but all too often you see code like there where they've got, the length which you control, and they've done some bound checking, like it's not bigger than or maximum value, and it's not smaller than 0, then it's okay. And then they come to this part and they say length, and at this part they're assuming it's bigger than 2, or at least 2. But you've given in 0 or 1, and basically you're under-indexing by a couple bytes. And for example, for string termination or something, and they'll add a 0 byte in there. And if you're under-indexing, and this is on the heap, you've got a lot of problems. Right. So these are some of the size fields that you want to take into account. Right. So strings. Obviously, you want to have long strings, really long ones. Just in case somebody left a trivial stack smashes or some stuff like that in their code. This is kind of the classic. And then also format string bugs, you want to look for those. So you put some format string stuff in there. The thing I've seen, which is kind of odd, or at least a bit disappointing, is that a lot of the fuzzing tools out there that are going to fuzz for format string bugs, they're going to use 1 or 2 %ns, or they're going to use %s or something like that. That's not that good. It's not really a good idea to do it that way. What you want to do is you want to use lots of %ns. You want to use 15 or 20 of them. The reason is that if you use %s, even if you use 10 or 20 of them, if the stack is laid out just right, nothing's going to crash. If you're going to use %ns, even 3 or 4 of them, if the stack is laid out exactly right, I mean, it's kind of rare, but I've seen it happen. If it's laid out exactly right, 3 or 4 %ns, it's still not going to crash. And obviously, you want to get it to crash. So, use 15 or 20 of them. And, it's almost guaranteed that it'll crash. I've never seen a stack that's that well laid out by accident. Another interesting thing in there is if you've got like strings and you've got some binary data in there, odd things might happen. You can usually, if you want to generate those, just grab stuff, get stuff out of def random or something. But if you look at the kind of C code that's there, this is very common code, by the way. It's exceptionally common code. Where basically you've got B is a string you control. You've just read it off the network, and you're putting it into this kind of thing. And go up to the first 0 byte, and then +1. You do memory location A, and then you scroll all the way over the array. Say as long as what's in B is equals to ASCII A, just increase B. And then after the loop, you want to jump over another one. What people forget here is that you should, in these kind of cases, check for 0 bytes, because if you don't, basically the string length will go until 0 byte, and then the second B++ will jump over to 0 byte and heap overflow. And this kind of code is exceptionally common. Right, so that's, right, more strings. Other things is like, when something expects a string, don't give it a string. Lots of null point references this way. If you got like single-threaded daemons and you got null point references, that's a pretty nasty denial service. The other ones, like if you got lengths in ASCII values, that's pretty common. And basically just try to do keep the size things in mind and just use them in ASCII values. And this is fairly common. A couple of months ago, I discovered a bug in Ethereal where it does this CC parsing, which is distributed compiling. And it has an ASCII protocol where they say an argument, and then they say the length of my argument, and then they give you the argument. And the code basically just took the length and put it in the silent integer, said, oh, it's smaller than my buffer. Let's give that length to memcopy, and there was a stack smash. right, so that's kind of like, these are kind of like the strings that you want to keep in mind if you're going to look at stuff that's going to be written in C. Some more interesting things, which is usually more web-related, is SQL injection stuff. Though it's not always that, at least not related as in like forms or stuff, but for example, a couple of months ago, a friend of mine came across some commercial product which had a web server, and he connected to it with a fake browser, and he had SQL injection in his browser version, and it would trigger an SQL injection bug in this commercial product. So it's not always in like posting to forums and stuff. You can have SQL injection in other places as well, but usually it's in web-related forums and stuff like that. Yeah, cross-site scripting. I'm sure everybody's heard about them. Some JavaScript alert or something. So yeah, if you're into cross-site scripting and stuff, you can probably fuzz a lot of cross-site scripting stuff. A bit more damaging stuff is directory traversals. If it's like FTP stuff, you can usually get out of, like in Windows, or at least there have been a lot of them, you can get out of your chroot or something like that. In like web servers and stuff, it can get pretty nasty, because if you can do directory traversals, you might be able to get command execution from there. It kind of depends on the way things have been made. And then the last one of strings is command injection. Like backticks, for example, or semicolon or something like that. And every time I find one of those, it kind of amazes me that people still make these kind of bugs. I mean, you've got like some high-profile daemons and stuff out there where there's this kind of trivial command injection. You give it something that'll gift you a shell as an argument, do backticks, and you get a remote root shell or something. Yeah. So these are kind of the strings that you want to look out when you're fuzzing. Right. Some more stuff. Basically, things that terminate or something or that mark its beginning. You can have like no bytes or just 4 zeros or brackets, stuff like that. And so basically, kind of things that you want to do is like not use them and just have it endlessly going on, for example, or put data that wasn't supposed to be off there anyway, and see what happens. If you can if there are ways in the protocol to escape them, to escape some stuff, try to escape some of these things that mark some beginnings or endings. It can lead to surprising results. And then put several of those off each other and see what happens. Right. How do you want your fuzzer to actually work? The way I usually do stuff is you define some states of stuff that you want to do, and then I just use ran functions to decide what state I want to use, and then just fire that off, and that works pretty well. Usually, when you do these kind of things, you'll be working in endless loop. Yeah, some of the the random stuff, arc for random, and some more stuff. Def random and def urandom are exceptionally useful. Def random might not be that useful for fuzzing, because in fuzzing you want to do stuff very, very quickly, and it doesn't have to be cryptographically secure. So def random might not be that good, because it's slow. But def urandom is wonderful. If you're going to fuzz, it's like, you can't live without def urandom if you're going to fuzz. Or at least I can't live without def urandom. And it's usually an endless loop that you do these kind of things. The other thing is that usually, and this tends to be more towards fault injection, if you have a very detailed analysis of what you're going to fuzz, and you've got all written down, and you've got months of development, because these kind of sequential fuzz usually take a lot of time to develop. You've got a whole list of stuff you want to do, and you just have a for loop. You go from first test case till the last test case, and it just run down your list. And that's usually finite in time to do these kind of things. So these are usually two kind of things that you want to decide how you're going to fuzz stuff. Right. The other thing which is interesting in design fuzzing is that you're going to either mutate data or generate data. And mutating data is usually a lot easier, because you take data that you know is going to be valid. If you've got a protocol, you sniff it and you say, this is valid because I've seen it work, it's valid. And you just put it in whatever you're going to fuzz, and just mutate it. Keep it as much intact as it was, but change a few things in there, and run it through. So data mutation is usually very easy to make. And it is amazingly effective. Yeah, it is. So the next one, data generation. This one takes longer because you have to figure out what you want to generate, and then still write code to generate it. So it takes a lot more time to program it, but you can cover a lot more code paths usually. Right. Some annoying things I've encountered while developing fuzzers is first of all, you've got bugs hiding behind bugs where one bug is so obvious that one bug is so annoying that will always trigger on something, and you will not be able to trigger a bug behind it. So that one kind of sucks. There are a few cases where you might be possible to get around the first bug and second bug, but because you're fuzzing, the first bug will always get triggered. So that one really sucks. User friendliness is it's really bad. Yeah, honestly, I mean, it's so annoying to fuzz some kind of program, and every time it gets a packet, you get a pop-up saying, this packet is invalid. I'm like, I know it's invalid. I want you to break, and usually it stops processing anything until you click OK. So it's kind of, user-friendly is really kind of annoying when you're fuzzing stuff. Yeah, memory leaks, arguably, you can say memory leaks are bugs or security bugs, but if it's like memory leaks, like 1 or 2 bytes every time, it's not that much, and you usually don't feel it, but they can get pretty annoying when fuzzing, because if you're spitting out lots of packets in an endless loop, every time you send out some kind of packet, it might leak 1 or 2 bytes. So after 5 million test runs, you've leaked 5 million bytes. And sometimes the leak can get bigger. So if you're going to be fuzzing something, and it leaks a lot of stuff and sucks up a couple of gigs in a couple of minutes, you won't be fuzzing it for long. Right. The other thing is, programs that are slow in general, they're annoying to fuzz because you just have to wait a lot longer for your results. Usually, though, slow programs are interesting to fuzz because, if they're slow for what they're doing, because that means the programmer probably didn't know what he was doing, and that usually also reflects in the quality of his code. Like in terms of security. So they might be annoying to fuzz, but on the other side, they're also interesting because you just know there are going to be bugs there. And of course, you can only fuzz what's configured. If things haven't been configured, you won't be able to fuzz those code paths, obviously. And then the other thing, which is I've talked about it before, but which is really annoying when you're fuzzing, is checksums, encryption, compression, all those things. Especially if it's compression or encryption that's not publicly known. It's not an open standard. It's stuff that you have to reverse engineer. That's pure hell. Right, so getting rid of these annoyances. Bug hiding behind a bug. If it's open source, track the bug down and just fix it. If it's binary, you're kind of not so lucky because if you can track it down and patch it in the binary, depending upon what kind of bug it is, it might be trivial, but it might also be very hard. You might also be able, which I'll cover in the next one, but if it's binary, you might be able to, if you can isolate where it is, you might be able to preload it. The second one is user friendliness. That one's really annoying. You can usually preload stuff. If you get like a pop-up for something, preload it and just get rid of that pop-up. The other thing is that on macOS, you've got something which is called AppleScript. And what's so cool about AppleScript is, well, I'll show you that in the next slide. But keep in mind that AppleScript is really cool for helping you fuzz stuff. Memory leaks, which is basically, arguably a bug behind a bug, because memory leaks on themselves are bugs, I guess. Well, again, if the same rules for bug behind a bug apply, if it's open source, fix the memory leak if you can find it. If it's binary, if you can find it and if you can fix it, because binary is obviously a lot harder to patch than when you got source code. But if you can fix it, try and fix it, because memory leaks do matter when you're fuzzing stuff. And then for like the other stuff, like slow programs and fuzzing what's being configured and encryption and stuff, there's usually no easy way to get around. Maybe configuration, maybe if you know what to configure, what not. But all the other things, there's no easy way to get around them. You're just going to have to deal with them. So yeah, that really sucks. But getting around some user friendliness, specifically on macOS, you've got AppleScript. And AppleScript is sort of a programming language, but it looks more like English than a programming language. If you can see the code here, basically this is something I've used to fuzz Internet Explorer on macOS. And basically what you do is you tell application Internet Explorer and then basically have a while loop in there and then open a Gopher URL. And this is pretty cool because in Internet Explorer, you don't have refresh when you're doing Gopher. You've got refresh in HTML, you've got no refresh in Gopher. And you could hit the refresh button a million times, but your fingers start hurting, or maybe they might even start to bleed, I don't know. But if you've got AppleScript, you don't need those things. AppleScript will do that for you. You'll tell AppleScript, do that what I would usually do, and it'll just do it. And besides the fact that you'll save a lot of pain in your fingers, it'll be faster because refreshing, you got human interaction, but this is just automated. So AppleScript's a godsend if you're going to fuzz stuff on macOS, but at the same time, it can cause problems because some applications on macOS, they either don't implement AppleScript and then you can't use it, or they've implemented it really, really badly, so badly that when you try to write some AppleScript code, the thing will just crash when you're trying to communicate it with it. So, but besides that, AppleScript's really, really cool. Right. Determining how stuff fails, because I mean, it might sound a bit obvious, but sometimes it's kind of nice to have some pointers towards how these kind of things fail. Obviously, crashes, usually those are pretty easy to detect. But I'll talk about that a little bit later, and very small snippet on the next slide. Huge memory consumptions, they can usually be found with default tools, and I have a slide about that as well. Reboots, yes, I mean, usually you notice a reboot, so. Same thing with hangs, you can usually notice them, but yeah, that kind of depends what kind of hang, and because sometimes, sometimes you feel hangs, but sometimes you just don't. I mean, if you're not looking at the application specifically, you might not feel it in your operating system. It depends on the bug. Right. So crashes, yeah. I mean, this is kind of obvious, but it looks cool though, doesn't it? Right. So core DOM attached debugger, and I'll be talking about debuggers quickly in a couple of slides. So that's basically, it crashed, and in this case, it's pretty easy to determine what's going on. Huge memory consumptions. This is from a real case, by the way. I was doing some fuzzing on Internet Explorer, and I made some bitmap fuzzing tools. And at some point, I came across some bitmap, and my mouse was hardly moving, and things were going very, very badly, and there was a huge load. So I hit Alt Control Delete, and I go to performance, and usually you see the page file usage history, and basically all my physical memory just was gone. Internet Explorer had just eaten all of it. So, and it's easy to see it here, and then at the the after picture, after Internet Explorer has died, after I've killed it, you see all the performance, it's all coming back. So it's kind of nice to see it in the graphical way. But usually it's easy to detect these kind of things. Yeah, a reboot. A while ago, I was fortunate enough to be at a friend's place who had a Cisco, and I figured, I've never fuzzed a Cisco before, so let's do that. And this was the result I got. I haven't played with it before because I know very little about Cisco devices, but it was fun though to see it break. And then you get some stuff in there, some registers, and then Cisco realizes it has crashed and it reboots. So it's kind of neat to see those kind of things. But hangs is, it's another Internet Explorer thing. Basically, if your CPU memory usage for some application never drops until you kill it, something's up. Right. So, seeing more than just a crash. This is just a couple of pointers. I really don't have time to go into detail on any of these things, but if you're interested in some of these things, you should stick around for next talk by Richard. He'll be giving you a really cool tour of some of the things in IDA Pro, which I mentioned here, and how you can figure out some structures of binaries and how you can use those for fuzzing, for example. You know, if you're fuzzing something, you know, try to attach a debugger. You know, you've seen GDB, but the thing about GDB is that it's not really that wonderful. I mean, it's nice if you have your code compiled with debug and all these kind of things, and you've sprinkled some printfs around and things like that. But if you're gonna fuzz things that will create threads and that will fork and that will call the execute system call, GDB is kind of bad because GDB can't handle threads that well. It basically breaks on a lot of thread stuff. Execute system call is just as bad. Fork kind of depends. If you're lucky, it doesn't. It does work. If you're not lucky, it doesn't. Auto debug is one of the Windows debuggers. It's pretty neat. I've looked at some of that stuff. Pretty cool. WinDBG is sort of like AutoDBG, but it's made by Microsoft. Softice is kind of like one of the huge debuggers in Windows. It's kernel debugger, and you know, if something breaks, you can get it to pop up. So this is just some of the debugs that you might want to look at. These assemblers can also be helpful if you fuss something and you've got an idea where it's gone wrong, but you don't know exactly what's gone wrong. You can fire up your disassembler and look at the entire program or large parts of the program. IDA Pro is obviously, I mean, this one's kind of unfair because like IDA Pro is like, it's like the disassembler. You know, there's not a single one that's better probably than IDA Pro. And Object Dump as well. You know, it doesn't really compare to IDA. Object Dump is a really simple tool. Sometimes Object Dump is useful. Usually it's not that useful though. IDA Pro is amazingly cool. You guys should, if you want to know some more about IDA, you should definitely stick around and see Richard's talk. Right. Yeah. The thing is that you should, when you're debugging stuff, try to keep track of everything that's forked and spawns that have been threads that have been spawned. Excuse me. If you're using GDB, you're kind of out of luck because GDB will probably crash on some thread stuff. Right. Some more utilities. For Unix, you've got strace and ltrace. strace will give you some nice information for system calls that we used, and ltrace does pretty much a similar thing, but for system calls. And on Windows, you've got a tool that FX developed, which is Dumbug, and it can do similar things. The other thing for seeing more than just a crash is looking at your log files. If you see something like that in your log files, you know, something's up. You know, somebody tried some kind of format string bug, and apparently they succeeded, at least in triggering it. Right. Okay. Extending existing fuzzers. That's one of the things that you should definitely do, because the thing with, like, for example, the Mangle.me tool from Mikhail Zalewski is that it was just scratching the surface. It only fuzzed a small part of HTML, and it didn't even cover anything else that the browser did. So if you just take any fuzzer that anybody ever made, just take it and look what it does, and then think about things they've forgotten. If you implement those, and then just run your tool against whatever they ran it before and all the bugs they fixed, just run it again, and I can almost guarantee you that you'll find new things. You don't always have to start from scratch. Just take other people's work, build upon it, and usually you find new things. Another example of this is, and this is actually a good one, is the Protos. The SIP fuzzing tool they had is, I mean, they've spent months trying to figure out exactly where things can go wrong, and they've worked things out in detail, and so they've covered a lot of code paths and a lot of devices or software that parses SIP, and so they've probably, if you run something against Protoss, you can catch most of them. But then a couple of months ago, somebody discovered a bug in Ethereal in zip parsing. And this was one of the main attributes of zip. And the actual bug in Ethereal was a trivial string copy where you had a stack smash and buffer overflow 101. But the thing is, because the guys from Protoss had run their tool against Ethereal, and they discovered several bugs in the zip parsing, but they had missed a specific one. So if you had taken the RFCs and look at the way people implement stuff, and you would have extended Protoss for this thing, you would have been able to find that particular bug in Ethereal. So even if people have put a lot of thought into developing fuzzers, even if they spent months developing a fuzzer and putting a lot of hours into that, they'll still have missed some things that you might think about. Just implement it, run the tools again. Usually you find cool stuff, right? So my conclusion, because I know you're all bored of me and you want to go out, but my conclusion is that fuzzing is amazingly cool. And even if I sound boring to you, you should still go out and try some fuzzers, because it's like you have to experience, you just have to experience fuzzing and see what it's all about and get this warm, fuzzy feeling the first time you break something. But so fuzzing is amazingly cool. Also, if you compare the amount of stuff that you can find with fuzzing in a time frame, and then see how much time it would take you to do a code audit and come to the same conclusions, it'll probably be like a factor of 10 or something. I'm not saying that you should get rid of code audits and only do fuzzing, because there are some tools that, some bugs that are hard or or pretty much impossible to fuzz that you might be able to find with code audit. But if you're just out to find a couple of bugs, fuzzing will save you a lot of time. I mean, I spent the last about 2 years doing an unhealthy amount of code auditing, and then I discovered fuzzing. It was like a whole new world opened for me. So you can find a lot of cool things in a short period of time with fuzzing, where it would otherwise take you days or weeks or months or even years when doing code audits. And fuzzing is probably the most widely used method of finding bugs these days. And of course, the final conclusion, the coolest one, is that people cannot write decent parsing code. Right, and this is, okay, some advertisement. There's a magazine called MISC, and there have been some of these around. I think there have been, the guys from MISC bought like 600 of them with them here. And it's a magazine about computer security. And this started off in France, and in France I think they're up to issue 22 or 23. And since a couple of months they've got MISC magazine here in Germany. And issue 3 contains an article about fuzzing, which a friend of mine made, and he's covered some of my things. So you should definitely check out MISC, it's really cool. Although I don't know exactly what's in it because I don't read German. But I've talked to some of the editors, and they've told me that it's a really cool tool. Magazine, yes, okay. Right, so some interesting links, and this is basically where I'll shut up then. The first one's Violating Assumptions with Fuzzing, which is a paper written by 2 people at Microsoft, Michael Howard and another guy whose name I've forgotten. And basically this is their experience that they've had throughout a couple of years at Microsoft doing fuzzing, and some of the things that they've noticed doing fuzzing. And there's a lot of cool stuff in there. If you get your hands on that paper, if you're at a university, you can get it for free. If you're not at a university, you have to pay IEEE 20 euros to get 5 pages of text. So, or if you're smart, you'll just bounce from some university and get it for free anyway. I wasn't that smart. I actually paid them $20 because I didn't know I could bounce off universities. But so if you're smart, you're not at a university, just bounce over some and just get it for free. But that paper's pretty neat. The next one's basically the talk that Dave Vitale gave at Black Hat in 2002 about Spike. You should definitely look at it. If you're interested in Spike, those slides are a good starting point. The next one is slides from a presentation that FX made, which I really, really like. And basically, at least from what I understood, that the slides or the talk was meant to show people that hacking is really hard work. Although it's really fun, it's a lot of work. And it covers more than just fuzzing. It covers fuzzing, adding statistical analysis and doing binary analysis. And then it also covers the exploit development and the making exploits reliable, and then something like don't use C because C takes too long to develop stuff in. So, but that one's really cool. It gives you a more complete picture. Right, the next one's a talk of two guys from iDefense who talked at Black Hat this year about file fuzzing. And that one's interesting too. If you've got some time, definitely check it out. Then there's the talk from Brett Moone, I think that's his name, from AtStake at the time, discussing Combust and how cool it really is. And if you manage to read that PDF, you'll see how cool the configuration options are in Combust. And then obviously, you know, some advertising for myself. You know, that's my website, and you can find some of my fuzzing tools there. And I've got a collection of fuzzing tools that other people made that you can find there. And I've made some slight modifications to some things that people made because I thought some things were off or wrong or they missed some stuff. And you can find them all there. If you're interested in fuzzing, or if I've got you all hyped up for fuzzing, you should go there, and there's some cool stuff there. The one under that is Advances of Block-Based Fuzzing, which is where Dave Vitale explains to people who read it how cool block-based fuzzing is and why not using block-based fuzzing sucks, or why it sucks according to him. The last one's about a talk that Matthew Franz did, Black Hat, in 2003, covering this PIF tool, Protocol Independent Fuzzer. And basically, the tool's more about showing people how good or how bad BGP is these days in terms of security. Right. That's about it. Any questions? Nope. No questions? Okay, that's good. Saves me time. Thank you.